This is Dr. Lewis, a question about acidity of organic molecules related to conjugation. So it says, predict which proton in the following molecule is the most acidic, and then by considering the stability of the conjugate base. Include resonance structures and curly arrows in your answer. So remember, it's all about an acid, and if it loses a proton, you produce resonance, you produce the conjugate base, the anion, and really that equilibrium and how far it goes from left to right is governed by this. How stable is that? And in this case, it's whether the anion has resonance, or which is the anion with the best resonance or the most extensive resonance in this molecule. So we have our molecule, and we can maybe draw it a bit bigger. So there are lots of molecules, lots of protons on it. We'll put them all on. We've got a CH3 there. So the ones that we can ignore are those directly attached to a double bond. So if they're directly attached to a double bond, they're in an sp2 hybridized orbital, which means that our p orbitals, which perform the pi bond of the double bond, are sticking straight up. Anything which is an sp2, such as that one, is orthogonal to it. So if you remove the proton, the anion you're left with is still in an sp2 hybridized orbital, and it's going to be always orthogonal to this, so it cannot be in conjugation with it. So therefore we can ignore all these protons there. It has to be a proton which is next to a double bond, not directly attached to a double bond. So there we have a choice of, there's another one there, missed that one. We've got these two, this one and this one. So if I remove that one, it's not in conjugation with this double bond because it's separated by an sp3 carbon. So it's only in conjugation, it's in conjugation with that one, but you get cross conjugation with this one. So this proton is in conjugation with that extensive double bond, so it looks like this one is the most acidic, so I'll circle that one. So if we remove that proton, draw a curly arrow to generate the anion. We can show the full extent of the resonance all the way up to there in one go. So rather than drawing two separate resonance structures, we can do that, and that will save you drawing lots and lots of structures. So now that curly arrow is going into that bond, or a double bond. That curly arrow is moved onto there, so that now is a double bond there. And finally, that double bond is moved onto the end, so the anion is moved there. So we have resonance over 1, 2, 3, 4 bonds. So in the conjugate base, of the circled proton, anion is in resonance over 1, 2, 3, 4 bonds. implies, so that's the most acidic one.